Hello, everyone, and welcome back. So we're talking about exponential and logarithmic functions, and we want to talk about evaluating logarithms. So there's one way of doing this. Well, there are two different ways, but let's first look at evaluating logarithms by converting to the exponential form. So if you had something like this, right, you had log, let's do blue. So log base 2 of 8 is equal to y. I want to solve for this y. I want to simplify and I want to evaluate, okay, what is this? What's the value of this y, right? Then I say, oh, okay, well, we know that if I were to go from this logarithmic form to exponential form, I say, okay, this is the same base. So I go 2 to the power of this side, y, is equal to this argument 8. Right? So I go, okay, well, 2 to the power of something is equal to 8. Well, okay, cool. Now we like not both, but we all know that 2 to the power of 3 is equal to 8. But let's say it was a slightly more difficult question, then what you do is say, oh, let me see if I can rewrite this side as the same base. Remember when we talked about writing it as a common base? I could write this as 2 to the power of 3, and I could write this one as 2 to the power of y. Don't change anything there. And so we can see that because of this argument, we can say that y is equal to 3, right? And so when I want to solve what is log 8 is equal to y, well, we've just solved this and we can see that log base 2 of 8 is equal to 3. Okay? All right, everyone. So let's have a look at the next one. Now, when we're talking about evaluating logarithms, there's another way as well. We can evaluate logarithms by changing the base. So if I wanted to change the base, so let's say, for instance, I want to evaluate something like this. Log base 5 of 50, right? So log base 5 of 50, now we're looking at this and we're like, well, how do I do this? Then we can say, okay, well, I can rewrite this as an exponential, sure, like we can take the same kind of method as the first one, and then we'll see that we're gonna fall into a problem. So let's say it's equal to some value v. Then I can go, okay, well, I take that same base 5 to the power of the other side is equal to this argument 50. And then I say, okay, well, I can't write 50 as 5 to the power of something. And so instead, I can write it as 5 to the power of 2, which is 25, right? And then 25 could be written as, so I could go, oh, okay, well, then 25, I can write it as, 25 times 2. And then I'm going to end up with something like this. I'll go 5 to the power of v is equal to 5 to the power of 2 multiplied by 2. But that's kind of iffy. Like we don't really like what's going on here, right? It looks a little icky. And so we say, you know what? What if I go, what if I say, okay, I'm going to go instead of 5 to the power of 2, I'm going to say 5 to the power of something a bit higher. And if I say 5 to the power of 3, then we can see that that's 125. And so I can't really use that. If I go 5 to the power of, that's 125. So this is not what we want. What about 5 to the power of 2? Again, we said that we don't want that one because that's 25. What if I go 5 to the power of 2.5? Well, that's going to be 55.9. We can see that that's again not 50, but it's somewhere in between these two, right? So it's 5 to the power of something between 2 and 2.5. So it looks like I can't really do it if I change the base. And so, at the moment, we're basically unable to evaluate what this is by converting to exponential form. And so we say, you know what, let's talk about common logarithms, because in this case, by evaluating logarithm by changing the base, like we did over here and like we're trying to do over here, sometimes it might not work because sometimes the base cannot be changed into the same, the base on one side can't be changed to the same base as the other. And so we introduced something called common logarithms. what are common logarithms? Common logarithms basically have the base of 10, right? So you go, so it's log base 10, right? Log base 10 of something, right? So an example of this could be log base 10 of 1,000, right? This is a good example. Basically, these are logs with base 10. All right, and you'll generally be using a lot of these when you're solving, but because they're, they're more useful. But log base 10 is called this common logarithm, and these logarithms are they're so commonly used that when a base is not given a logarithm that is understood to be a base of 10. So if I had something like this, for instance, if I had log 20, that basically means log base 10, right? Because that's how commonly used they are, that you don't have to put the 10 anymore. Okay. So basically, if if I wanted to evaluate something like what is log of 89, right? So if I had log base 10 of 89, well, what would I do here? Then I'm saying that this is equal to v. And I'm saying that something to the power of, sorry, 10 to the power of v is equal to 89. And so I fall into the same dilemma that I had over here. Something to the power of v is equal to 50. And so we know that 10 to the power of nothing will give me 89, but what we can do is we can put this in our calculator. Let me show you what you could do in your calculator. So you go to your calculator, you go log, and once you do log, it's understood. If you press log something, it's understood that it will do log base 10. All right, this is the same as of something is equal to the same as saying just log of something on a calculator because it's a commonly used one. And so you can go, oh, okay, well, log of 89. And that gives you 1.94 or 95-ish. So V is equal to 1.49. And so sometimes you'll be stuck in a situation where you're like, oh, this is not something that I can do freehand, and so I need to use my calculator. You could estimate, right? Like we estimated over here that it should be somewhere in between 2 and 2.5. So our V value should be like, I don't know, 2.25 maybe, like, we're guessing. And so you could give an estimate, but in order to get a correct answer, this is where you want to use your calculator. And so sometimes, sometimes you just can't do it freehand, and that's why we're looking at common logarithms where you can do it on a calculator, and natural logarithms where you can also do on a calculator. Natural logarithms is where we have the base of e. So this is logs with base e, right? The e, which is 2.27, so on and so on. This irrational number, right? So the value of this is going to be determined again by putting it in the calculator. And what I want you to recognize is that something like this is also very common, that it got its own name. This is called ln. You read it as ln, like lawn, your lawn outside. All right, you read it like that. And basically this is called the natural logarithm. All right, and you're generally going to be using this depending on your teacher. You might be using this a lot, you might be using this very little, but in higher maths you stop really using log, and this is the more common one, the natural log. And so over here when I talk about log base e, so if I go log base e of 5, this is the same thing as saying ln of 5. Okay. All right, so this is pretty much it, what I wanted to talk about of natural logarithm, just for you to be able to kind of recognize that. And then one last thing is changing the base, okay? So changing the change of base identity. So if I ever want to change this base b, right? If I have log of base b of c, I could always write it as one common log, right? Like I can go, oh, okay, well, that's log of A of C. So this top one divided by log of that common base of this bottom one. Okay. And a good example of this is if you had something like this, log of 2 of 64. All right. Then you're saying, okay, well, how do I do this? Then I'm saying like, I need to solve what that is. And so you're saying, oh, 2 to the power of v is equal to 64. Now, here's the thing. 2 to the power of, uh, let's see, 2 to the power of, let's say, 6. Yeah, 2 to the power of 6 is 64. But here's the thing. Let's say it was something that you cannot solve, okay? So it's something like this, right? Let's just do that one, right? So you have log of 5 of 50, log base 5 of 50. And we said that, we could estimate this, but really it's not that simple. And so what I can do is I can use the change of base identity to get the actual value. And what I'm going to do here is I'm going to change it to the common logarithm, right? And that's why I wanted to introduce this to you, is because by changing it to the common logarithm, it makes it very simple to put this in a calculator. So over here, I can go, oh, okay, that's log. I can go log base 10. So the original log, right? Log base 10 of the top number, which is 50, divided by log base 10 of our bottom one, which is 5. I put this in my calculator, so I go, okay, what is log 50? So I make my fraction. I go log 50, right? And remember, when you press the log button, that assumes that you're doing log base 10 anyways. Log 5. So here's what I have, right? I have log 50 divided by log 10. I got what that's equal to, and that's equal to 2.43, right? So what v is over here is 2.43 approximately. And how we did this is we did a change of base identity where I said, you know what, since I can put them to the same base and then just take this top number, divide it by the bottom number, then I can do this for any time. It's not a straightforward one like this 2 and 8 or like what we had 2 and 64, okay? And so over here we get approximately 2.43, okay? All right, everyone, so that's it for evaluating logarithms. We covered a few topics here, how we work with natural logarithms, how we work with common logarithms, so those to the base of 10. Sometimes we can evaluate directly by doing a change of base like we did over here. But sometimes when we do change of base, we're stuck with something that doesn't change to the other side. And so we need to estimate, or we can do change of base identity in order for us to evaluate this correctly on a calculator, okay? All right, everyone, so that's it for this question. I hope that helped, and I'll see you in the next video. Bye.